So we're entering the section on exponential and logarithmic functions. At this point, I want to take a little time to review what we've already learned about functions and the types of functions we've learned about. Then I want to add another category of functions that we haven't seen, called transcendental functions. And within transcendental functions are exponential functions and logarithmic functions. The main class of functions that we've already discussed fall under the category of algebraic functions. And algebraic functions consist of polynomial functions and rational functions. Again, polynomial functions are functions with many terms. Then we have rational functions, and we said that when we think of rational functions, we think of ratio or fractions, and these are represented by the division of one polynomial expression by another polynomial expression, as seen here. Now the next two functions we're going to talk about under transcendental functions are really aspects of the same thing. Exponential functions are functions that take the form of y or f of x is equal to b to the power of x, and logarithmic functions take the form of log sub b of y is equal to x. In both cases, b here is the base and x is the exponent, with y representing our answer. There are a few common bases used when we're using logarithms, and which one we use depends on which type of calculations or which subject we're talking about. In general, base 10 is referred to as a common base, and it's often used in financial calculations and some biological calculations. When the base of a logarithm is 2, it's referred to as binary, since binary means 2. And these are important, particularly in the field of computer science and advanced mathematics, where they're used quite a bit. Base e is a natural logarithm, and that's also used heavily in biological calculations, as well as financial calculations for things like investments and earnings. If you've never seen, heard of, or used logarithms in the past, both their looks and their uses may seem strange to you. So let's talk a little bit about them and where they came from. The term logarithm itself comes from the two Greek words logos and arithmos. Logos meaning proportional and arithmos meaning number. When you think of proportion or logos, think of scale. If you've ever seen a model car that gives you the scaled size to the real car, such as 1/50th the size of the real thing, these are the types of proportions we're talking about. With that said, two main uses for logarithms are when you're dealing with large differences in data and you want to chart it or represent it somehow on the same scale. The next most common use is when you want to focus on how a relationship changes based on percent rather than amounts. In plain English, we would say that logarithms give us a way of simplifying measurements that have a wide range of values, so the numbers are easier to work with. It basically reduces tedious multiplication and division operations into arithmetic operations. This is very important before the advent of calculators and other automated computing devices. Logarithmic functions are often defined in terms of the exponential form and logarithmic form. That's why we said they're really two aspects of the same thing. Let's consider a real-world example. Most people are familiar with the concept of pH, and we know that a pH of 7 is neutral, being neither basic nor acidic. As you go lower, the acidity increases, and as you go higher, the basicity increases. But a lot of people don't know what pH actually means. Simply stated, it's the negative log base 10 of the hydrogen ion concentration of a solution. Since this isn't a chemistry class, we won't worry about the units used here, which is molar, in case you're wondering, but we'll focus on the numbers. A pH of 1 is represented by 0.1, a pH of 2 is represented by 0.01, all the way up to a pH of 14, which is represented by a point with 13 zeros and then a 1. It's easy to see now how dealing with pH is a lot easier than dealing with hydrogen ion concentrations. Let's take a break here. When we come back, we'll take a look at some examples and some operations that are commonly used to manipulate logarithms and exponential functions.